Aida to deliver his speech. Thank you. Welcome.
Assalamualaikum and good morning everyone. Thank you so much to Mr. Helmi Wahab, and I would also like to thank, this session is for the AI course, right, at FKE. I would like also to thank Computational Signal Imaging and Intelligence Focus Group at FKE for inviting me to share on the topics. Okay. Let me share my slide. Okay, slides good?
Yes.
All right. Okay, so for today, we are going to have some insights, or I'm going to share with you an area of studies which is called conversational agents. Specifically, we are going to look into chatbots, from chatbots to humanoids. Okay, now the origin of this area, in my experience, started when I was pursuing my master's degree. I did part-time basis, industrial background. I have no idea on how the academic and everything. And so what happened, I chose this topic chatbot as my dissertation topic. My supervisor at that time was Prof. Azuraliza Abu Bakar from UKM. I did my master's part-time at UKM. And the reason I chose natural language processing, because I self-proclaim myself as a writer or a poet. I always use that, but it is self-proclaimed, and it is my passion in writing, in language. And coming from the science-based academic background, that comes the computer science studies. So in computer science, there is a branch, specific branch called artificial intelligence. And within artificial intelligence, there is a subfield of natural language processing. Now, it used to be called natural language processing, but now it has been rebranded into computational linguistics. Okay, so the main textbook, when I was studying this, when I was doing my PhD, because I pursue my PhD in the area of computational linguistics as well, and I self-learned AI. So basically, the main two textbooks that you'll be needing is, the first one is this, okay? This is Artificial Intelligence, A Modern Approach by Stuart Russell and Peter Novick. This is a very old book. My version here is in 2003, but there will be available PDF versions online, but I don't encourage you to buy online for the copyright purposes. So the first reference would be the AI textbook, and for natural language processing, this is the main textbook, okay? It is called Speech and Language Processing by Jurafsky and Martin. And that is the latest one is currently available on PDF 2020. And there is now a specific chapter on chatbots and dialogue system. I don't think I have it. I don't think that the old version have it. They lump into dialogue system, but not chatbots. So chatbots comes as another topic, subtopic in the latest version chapter. Okay. So back to the story of my master's project. So what I wanted to, what I proposed to my supervisor was that I want to build a boy, a so-called hypothetical boy, that would grow in my family and keeps log of every single details of tiniest conversation that happens in the family. And from time to time, we or the users are able to teach the boy some stuff, new stuff, whereby the idea is that we can set him into a learning mode and give him new input so he can store inside his database. So over time, he so-called, grow because the database or the knowledge base is actually growing. So I built it for my master's project and I named it Luqman Hakim. It is an acronym for Learnable Conversational Agent with Heuristic Knowledge Management. I have no idea on the keywords. It sure sounded scientific, but heuristic knowledge management, those opens to a different field under artificial intelligence, heuristic learning, meta-heuristic learning, but that is another lecture. So what happened was, one day I told the bot that Dad has just got a new haircut, and it was a very ugly haircut. So I went on complaining to it by typing how ugly he looked. And a few days later, the dad, my husband, actually sat down and chat with him, or it, the bot, and to his surprise, that the first thing that the bot asked him was, "Did you have a bad hair day?" So of course, the dad freaked out, and he asked me, how the heck did he know that I had a bad haircut, because I've been complaining about his bad haircut. So I explained, of course, it didn't know. He was just associating a bad hair day with a bad haircut, because technically the keyword bad hair does exist in the conversation log, because we talked about it, and he was associating. He picks up the response, the keyword hair, randomly from my bad haircut to a pre-recorded response, a bad hair day, in his pre-recorded response in his fixed database. I was using a flat text database. It was very old technology. So basically, there is nothing fancy to it, and there is also nothing new about the technology. Chatbots. It exists. The first chatbot that exists is called Eliza. It started in 1966 and created by Joseph Weizenbaum. It is an early natural language processing program. And what interesting about Eliza is that what makes her successful during that time, and being the first chatbot available ever, because that she plays the role of a Rogerian therapist. Now, Rogerian therapist or Rogerian reasoning is a conflict solving technique based on seeking the common ground, whereby the psychologists or the therapists usually play the role to ask more information from the user rather than offering solutions. So if you see down here, there is a clip of chat from a patient with between a patient and Eliza. Okay, if you see the pattern, you will see that Eliza is actually not responding to anything. It is simply mimicking whatever that is input by the user by taking some keywords and then direct match with the pre-recorded response. And when we actually see inside Eliza database, they have one, for example, one keyword, hair, and there are multiple lines of pre-recorded response. And this response will be taken randomly. So after a while, if you chat long enough, you will see that the patterns reoccurring, the response coming back again and again, and sometimes at inappropriate times, okay? So for example, the patient says, men are all alike. Eliza said, in what way? They're always bugging us about something or other. Eliza said, can you think of a specific example? Well, my boyfriend made me come here. Your boyfriend made you come here? He says, I'm depressed much of the time. I'm sorry to hear that you are depressed. It's true, I am unhappy. Do you think coming here will help you not to be unhappy? Okay, so if you go through, you will see that Eliza is picking up keywords, as I explained, keywords from the utterance. And in natural language, usually if we have a body of text like a corpus or a textbook or a paragraph, we call it, the complete unit is called a sentence. But in conversation, we don't call it a sentence, we call it an utterance. And specifically, what is unique about utterance is that utterance can be short, it can be one word, it doesn't have to be grammatically correct. So that is the main challenge the main challenge when we deal with natural language processing, specifically for conversational agents or chatbots or humanoids, because the response has to be random and it has to be robust enough to understand and to do the associative process from the keyword that the user throw to whatever knowledge that you have. So if my previous example just now, I only used the flat text and it was very small database, but the idea is that when we trigger certain keyword, we will change the learning mode, so-called the filter, and it will add automatically with a pen line to that text base. And I'm sure you're already familiar with that. Okay. So some brief timeline. We had Eliza in 1966, and then in 1972 we have Perry. Now, if Eliza is playing the role as a Rogin therapist, Perry is actually playing a role as a patient, as the paranoid schizophrenic patient. Okay. And then comes other variation in 1983. There was Rector, 1988, Jabberwocky, 1995, Alice, 2001. More commercial ones coming in the 2000s, in the era of 2000s. IBM Watson's in 2006, 2010 Siri, if you remember, if you use iPhone, which I don't. And there is Siri that able to answer in natural language. Basically you can imagine as a search engine, but not text based, it is voice based. 2012 Google, and then 2015 Alexa, Cortana, and so forth. And if you Google in the website, you will see certain variations of timeline. And I'm not sure because the source of the figure that I took is actually from altexsoft.com. The link is down here. Okay. And there are some variants of years. Different web pages refer to different times. What would be interesting for you to search on is the chat transcript, which is very funny. The first one I would like to check later is the conversation between Perry and Eliza in 1972. And remember, Eliza is the doctor, is the Rogin therapist, and Perry is the paranoid patient. So the conversation is very kelakar lah. It's funny. So there's another one when Siri met Eliza. That was in 2011. What happened was this Jordan Magner, he coded Eliza response to talk to Siri, and there is a full transcript of the conversation log as well, so you can check that out. Okay, so what is a conversational agent? Basically, it is a computer program that converses with human in natural language. It is also known by many other names: dialogue agents, dialogue systems, chatbot, chatterbots. And these are the definitions that I took, that I snipped from the web. A conversational agent is any dialogue system that not only conduct natural language processing, but also responds automatically using human language. Now, there are two things. It can be text-based, and it can also be speech-based. So regardless the input, whether the input is in speech, as in you are talking to me, or if the input is in the form of text, as in you are texting to me, assuming I'm a bot, and it all boils down to the dialogue engine in a conversational agent or a dialogue system. Okay. Again, we call it many names. In academic, if let's say you want to write papers, you want to do research for your PhD, for your masters, you use the term conversation agent or dialogue system. We seldom use chatbot. Okay, so bots, what are bots? Bots basically are a computer program that is designed to perform repetitive automated tasks. So they take away our mundane tasks, such as reminding us for our dental appointment, or when to go to pay bills, or when to take our car to the service center. And bots also take away annoying tasks, such as booking a movie or checking account balances. Do you remember the dial touch option? Press 1 tekan 1 for bahasa, press 2 for English, why, something like that. I don't remember. And it drives me nuts every time because there is no direct response to 0. I cannot cut the options. We have to wait sequentially. So if let's say the system has 9 options, have to listen until 9. And during those time, it is very nerve-wracking because I was running from prepaid. We don't have postpaid those times. Okay, so basically, how do these bots work? Now, the figure that you see here, this is a generic figure. This is all that exists to describe a conversational agent or a dialogue system. You're going to spend a bit more time here. Okay, so basically, you will see that at the heart of a dialogue system or a conversational agent is a dialogue manager. You see this bot here. This is user. This is you. And user takes input speech signal user in the form of user utterance, assuming that this is a voice-based chatbot. If it's a text-based chatbot, then the input speech utterance, the input utterance would be in text. Okay, then there is a natural language understanding part. And then there also a natural language generation part to generate back the response. And then if let's say again, if the system is speech based, then we have an additional module, speech synthesis, to convert from the text back to the speech, and it goes back to the user. So now let's assume I'm a bot. You are the user. Okay, I receive input from my partner, which is you. When I receive an input, it can be text-based, or in case you're texting me, or it can be speech-based in case you're talking to me, or like speech-based apps like Siri and all. Now, regardless the medium, when I receive the input, I perform natural language understanding tasks. By first, there are a few tasks here. By first, I would definitely do tokenization, whereby I would split your whole utterance. Remember, utterance is a sentence. I would split all the utterance into tokens or simply words, and there are other nitty-gritty things that will happen here. For example, if you get you want to do stemming, because if you get words with prefixes or suffixes, you want to remove that, because you will not it is to simplify or to facilitate your database matching later, because in database usually we store the root word, we don't store all the prefix and suffix. Okay, so tokenization, I split into words, and then I might do stemming, I get the root word, and then I might do name entity recognition. Name entity recognition is whereby, before that we do post tagging. Post tagging is part of speech tagging. So given all the root words, root, and we will tag as, okay, this is a verb, this is a noun, this is an adjective, this is a verb, this is a noun, this is an adjective. Okay. And next only, some modules, some system, they have name entity recognition module, whereby from the noun, we further classify, okay, this is place noun, this is person noun, this is historical, I don't know, it depends on, in specifically to your domain, okay, a location, a time, a ranking, like jawatan in university system. So it perform name entity recognition, salutation and all. Okay. So after that, then only when I get whatever that I want, when I further understand the keyword that I have, for example, when I extract word ibu, I must be able, the system myself must be able to differentiate between ibu as in mother or ibu negara as in capital city. Okay, because both use the word ibu. So once I get that, then I will start searching in my memory or my knowledge base what would be the best response that I should return to you. So when I do the searching, trying to find the answers, trying to figure out, that comes the role or the task in Dialogue Manager. And in Dialogue Manager, there are many strategies. We will cover that a little bit later. If you see here, it says interpreted dialogue X. So in addition to the semantics or to the meaning or to the contextual meaning that you get, that the system understand from your input. Now, for example, I know that it is ibu as in mother, not ibu as in ibu negara, capital city. We also, there will be in advanced system, they will have a module called a dialogue act interpreter. Now, dialogue act is about intention, because that's how human works. We don't respond, conversation is very unique. As I mentioned to you, utterance can be short, it can be grammatically incorrect, it doesn't matter as long as it conveys the meaning. So that meaning is actually what we call intention in natural language processing studies. So there is a specific area on this. Dialogue acts, dialogue act recognition, dialogue act classification, a lot of things. So the intention is that, you imagine, if let's say we are talking together, if let's say you are just next to me here, and I tell you, it's cold in here. Let's say I tell you, could you please pass me the pen? Now, a grammatically correct answer in linguistic should be, your answer should be, yes, I can. But as a human, that is not what I want you to do. I want you to actually pass me the pen. That is called intention. Or if I say it is cold in here, I am not asking you to agree with me that it is cold or disagree, but I would rather you as a partner of or as a person next to me to do something about it. If it's cold, then maybe you turn off the fan or turn off the aircon or open the window to get warm air. Okay. So that is the dialogue act part. So on top of the context, the meaning that we already understand from the natural language understanding part, and we get the intention. There are layers of linguistic layers. The top one is, I think, at acoustic level, I cannot remember, but there is a lexical, there is a phonetic level, at the sounds, at the level of sounds, and then there is a lexical level at the level of words, then there is a semantic level, that is the meaning of words. Then after semantic, there is a pragmatic level. It covers the whole context. Okay. Same goes, when we talk about pragmatics, there is an area in AI. Long time ago, people start doing auto marking, like a computer program that will able to mark essays, for example. So if this program were to mark essays, this program should not read and understand only sentence by sentence. It has to put everything in context. That is pragmatic. Okay, so in a conversation, we cannot also analyze a conversation, or sometimes we call it a discourse. We cannot analyze from the level of utterance only, because the utterance change, the turn change. Turn taking is another area which is very interesting in natural language. Turn taking is when do you decide? If let's say we are conversing together, two person. So when actually you decide to answer or to start a word, either by waiting for me to finish off, or you can jump in. So there is a what we call initiative, turn-taking initiative. It can be from the system, because we're talking about the conversational agent, can be from the system, it can be from the user, it can be mixed initiative, meaning both participants, human and also the bot, can interrupt each other. That is most fluid or natural dialogue system, because it naturally reflects human. That's what we do. We jump to other people, we cut people short, and we talk more, So then we go to once the system already know what is it needed from the user, and if the system has found something, an answer in the dialogue manager, I would start to generate. So this is a natural language generation. These are different areas in natural language processing. Natural language understanding is an area, a big area of its own, where I mentioned about all the processing, all the text processing, tokenization, post tagging and everything. And natural language generation, there is another area. I did my PhD in natural language generation because when I submitted the proposal, I submitted proposal for PhD. Remember, I came from part-time program for masters. So having the idea to do this bot thing. Then when I go to PhD at UPM, and the proposal was rejected for the reason there is no academic contribution to it. So bots are really interesting. You can do it as a project, especially undergraduate project, because you can explore a lot of things, a lot of domain. And it can go to master's level if you have certain theoretical parts behind it. Like my master's, I was exploring the concept of agency in conversational agent, and I was using the Gaia methodology, and now it's an obsolete methodology anyway. So natural language generation, there is a whole area of it. It can be basically it is either rule based or knowledge based and knowledge engineering. That means from syntax grammar. You remember the Chomsky grammar, and then later as time grow, as the technology grow, and we have more and we have more computing power, then we start to have statistical natural language generator. So whereby we can learn from corpus. So rather than hard code all the grammar, so we can learn, we can get these systems to actually learn. We feed with corpus. Corpus is basically corpus or corpora. It's basically a body of text. Can be paragraph, can be newspaper, can be from the website, Wikipedia, whatever. Okay, so we can learn the statistical natural language generator. We learn statistically the language model, and there are whole area of that. There are bigrams, there are n-grams, bigram, trigrams, and a lot of language models. They're very interesting. You should go and check that out as well. And there are also AI approach. I did classification and ranking approach for the natural language generation, but I did focus on utterance because I don't want to let go my, my conversation agent thing. Okay, so then after I choose a response, be a pre-recorded response. Pre-recorded is a direct matching. So I have one keyword, hair, that I extract from conversational log, bad haircut, and I match, and the system match with another hair with an idiom, bad hair day. Okay, and remember there are a lot of response that the system can choose randomly. That one, that is just, and that is really up to you actually. And there are other ways of doing this, template based. For example, if we have reservation system or booking system, so we have a pre-recorded template. We don't want to hard code everything because, for example, I have a show. I don't know what's the latest movie now. Yeah, it's MCO. Haven't been to movie for quite some time. I don't remember. What, any movie? Spirited Away. It's a very old movie, anime movie. Okay, so I wanted to say the Demon Slayer. So for example, the cinema will have show times, multiple show times in a day for Demon Slayer alone. And for example, they have Demon Slayer 1 o'clock, Demon Slayer 3 o'clock, Demon Slayer 5 o'clock, and that is for one cinema. And what if Demon Slayer Damansara Utama 1 o'clock, Demon Slayer one utama 1:30 o'clock, and there are a lot of show times. So in that kind of system, we don't want to use pre-recorded response at all. It's crazy to code all the possibilities, and it's not practical. It's not only crazy, it's not practical. Okay, it doesn't make sense. So we use pre-recorded response, whereby we use a pre-recorded template, so that we can fill in the values. For example, the user asks for movie equals Demon Slayer, then we slot into the template, and then we find the time that they asked, then we have a pre-recorded so-called template. Or we can automatically generate by using statistical generators there and then. So that is a truly robust system, whereby you generate, and this is where, the believability of a conversational agent comes in place, whereby it reflects more as a human if the system can do that. Okay, because if you are chatting and then you see that your bot or the system suddenly reply with 5 lines of answers in an instance, so that shows that's very unrealistic. And it is more of the system now, they simulate human behavior, like backspace, we type, and then we backspace to correct our sentence, and there is a pause in the system, showing just to simulate us human thinking before answering something. Okay, then finally, again, if let's say it is a text-based system, then the final utterance will be, the final response will be sent back to the user, to you. But if it is the case of a speech-based system, it will be converted by a speech synthesis module, whereby it will convert back to the speech signals. Okay. So what did I miss? So basically we have natural language understanding part, natural language generation part, and the dialogue manager, 3 main components. The language understanding produce semantic representation appropriate for the dialogue task depending on the domain. The generation would have to choose the syntactic structure and what are the response to send back to the user. And the dialogue manager is actually where the response strategy holds, what to answer, in what form, and it has to get enough information from the natural language understanding unit. Okay. Okay, so yeah, I covered this as well. These are dialogue management strategies. If you see, I mentioned about initiative. Okay, it can be a system initiative, or user initiative, or mixed initiative. And basically there are 4 types, 4 dialogue strategies that exist. This is from the textbook. And first is finite state, frame-based, information state, and the last one is plan-based. Plan-based, I will cover in the next slide. Now in finite state, you cannot jump. This is the case of, when I tell you I was calling from prepaid and going to all this reservation system, you cannot proceed until you have confirmed and a response for something. I mean, if it's a train booking system, we cannot proceed unless you get the system knows where you want to go, what is the destination. So frame-based is similar to template-based. We have frames. For example, origin city, from what city you're living, destination city, these are the slots that we have to fill in. Where are you going? Departure time, when you like to leave. So this comes from this link here. Okay, you can check the lecture notes here. And information-based is basically relies on semantic information. For example, the user say, I'm looking for a cheaper restaurant. So what it needs is actually price is cheap. Okay, the context is information equals price equals to cheap. And then the user says Thai food somewhere downtown. And then the information state expand, price must be cheap, food must be Thai, area must be central town. Okay, so that information based. And the final one is plan-based. Plan-based is what we call it a BDI strategy, belief, desire, intention. Now BDI comes from the area of software agent under AI as well. So what happened, it has the same, it doesn't follow the generic dialogue system structure that I showed you just now, because just now we have natural language understanding, natural language generation, and the dialogue manager. But now they the architecture reorganized or represented in the form of belief, which is the ontology or the database, the belief system of the belief of that system, then the intention or the plan, hence the plan-based strategy of the dialogue manager, and the desire, what is it that you want to do. So again, this is it can be for example it can be represented in the form of agent, hence the keyword conversational agent. Okay, so you have agent, speech agent synthesis, we have a voice agent that performs speech agent synthesis, and we have a voice agent to do text to speech synthesis. Okay, and we also have ontology. Now the way it works, user voice input from user received by voice agent, speech synthesis is instantiated. BDI is very object oriented. Okay, so the dialogue agent is instantiated. The dialogue agent posts an event whereby it sends text-based input tokens, and the rest. Okay, I think I'm running out of time. Okay, so but what I want to highlight here is the use of ontology. Now, in my case, Luqman Hakim, those days, I just use TextPad. It is a flat text-based knowledge base or database. Okay, and you can use Access or SQL. No, SQL is the query language. You can use any database basically. So what happened is, in BDI strategy, we promote the use of ontology. Okay, now before we go to ontology, wait, let me just emphasize this a bit more. Why we do the BDI strategy? Because the idea is that we want to detach the database, as I mentioned, the knowledge base, into portable ontology scheme. So if you see here, this is the ontology. Okay, and it is represented by objects. For example, you have fan. This is for ambient system project that I did before. So I have a system, I have entities named fan. Light is boolean, is fan off or on, is light on or off. And then I have air condition, and I have count light to count how many lights there is. Okay. So what is most important or most interesting, or what is robust about the BDI strategy is that we are going to detach the database into a portable ontology scheme. Now that scheme is straightforward enough to be maintained by a non-technical user. That means if let's say the ontology, you can skip, you can add more ontologies. Wait, let me show you this. Now the idea of ontology is for scalability and modularity. So more agents could be incrementally added to the engine. Excuse me, you have ontology agent, you can have the sorry agent, an agent who do all the translator agent, you can do calculator agent, you can do a lot of things. So basically you are, you are structuring your knowledge base or your database into objects. This is the sequential versus object oriented paradigm. Okay, so back to here, the BDI strategy also relax the full-blown parser to a shallow one to optimize speed. Okay, full-blown parser. In natural language processing, there is a task called parsing. So a full-blown parser will take in all the statistical, all the language model, and try to parse and understand one by one. And we want to remove that because we want speed. We want a system that is very robust, very random. You don't have to be correct. You don't have to be grammatically correct. You don't have to be, the system just need to be believable, okay, and enjoyable. That's what a conversational agent is supposed to be. And we also want to remove hard coding of response template. Okay. I have this paper. I think this was back in 2003. This paper is actually the reference paper where I mapped the strategy from the generic dialogue management, dialogue system structure, natural language understanding, natural language generation, and the dialogue manager, and map into full BDI agent. Okay. So we're done with the anthology. Now, how do you evaluate chatbots? Because as much as we want to believe, you know, it has to be a believable character, because we don't mind if the bot that we are talking to being grammatically incorrect. We don't mind if the sentence are not complete, okay, because that is what conversation is about. So in order to measure that, there is an old test that usually been carried out that used. It is called a Turing test. This exists by this was created by Alan Turing in 1950s, way before ELIZA came into existence. Okay, and basically in Turing test, we have assuming that you have a bot, so we have 10 subjects. We get all the students from the same class, and then to check if it's voice, then it's voice. If it's text, then it's text. So you chat, and then you tell, are you talking, do you believe you are talking to a human? Okay, so the Turing test says the program is successful if the user believes that the system is actually human. Okay, so this is one methodology, a very recent one, acute evaluation. If you see down here, and I put the reference for this paper as well, you can read more on that. It says here, the acute eval method asks annotators to compare two dialogues and choose between speaker 1 and speaker 2. Okay. Would you prefer to talk for a long conversation? For a long conversation, as a user, would you prefer to talk to speaker 1 or speaker 2? Okay, so all the speaker, it's actually when we do the Turing test, you have the subjects or the users, and then you must have behind the screen, there must be a real human mixed with the program. So people don't know actually, are they getting a conversation with the program or in actual human. Okay, so basically the idea is that if the users are fooled to think that the system is a human, then the system is considered successful. Okay. And back in 1991, there is a Loebner Prize, annual competition. This is they do competition to evaluate, to compete, to all the bots compete together. They have competition running from 1991 and until 2019. So if you undergrad students, you have some projects you can start doing from now, and try out for the competition. I don't know what happened to 2020. Maybe COVID thing, and they don't run the competition anymore. Okay, now then comes the humanoid. Humanoid having appearance or character resembling that of a human. Now humanoid, as in other oids. Oids means resembling something. Factoids, trapezoids, other oids. Cuboid. Cuboid is actually referring to a cube like, hence cuboid, not necessarily a cubic. Wait, I accidentally click on the link because the slide is full of links. Okay, we go back here. Okay, now humanoid has different takeaway from a chatbot, which is the look. Okay, it's the okay, we see this. Okay, it's the line, the wrinkles of the skin, the glitter in the eyes, the frown, the brow, and these are examples of humanoids. You can find more. I will show you links after this. The first one is Hubo from the Hanson Robotics. Sophia also comes from the Hanson Robotics. Now, these two fella here is the Humanoids, and only one is the humanoid. The other one is the creator. So this guy, I think Hiroshi, I don't remember. This guy is actually the creator, and this is the oid. I hope I get them correct. Okay. So you can have the links. You can read more on Hugo, Sophia, and the Humanoids. And there are also other language, other speaking language. No, there are also bots, humanoids speaking in other language. For example, Erica, who speaks Japanese. This was built in 2015. Ibn Sina, Arabic, built by UAE 2009. Nadine is from Singapore. It's an English base. And Jiajia, and you see, it's very beautiful. Jiajia, 2016 from China. Okay, so I'm going to, these are just reference or ideas that you can carry on if you're interested in doing this. This was my work in 2004. And then after I finished my PhD in 2008, I went on building Akila. It's a dialogue-based visualization for Quranic text. And we have this copyright on Quran ontology for Juzu Amma. So, but we lost the dialogue system. So basically, if you build the dialogue system, the ontology is already ready for you to, converse. And this come from an undergraduate work at UPM, dialogue-based trade information system. So what happened? We built. This is just a dummy page. Okay, the student did for KTMB. No, hypothetically, we don't have any deal with KTMB, but basically it is a trade information system. If you see, I want to go to Kajang, please state your origin, Sedang. So the destination is Kajang, the origin is Sedang. Would you like to have one way or two way? So this was done template based, okay, in 2010. What happened? The student work was then being able to send for copyright. We obtained copyright for this in 2011. Okay. This is an undergraduate work for final year project in UPM. I was in UPM from 2013 until from 2003 until 2014. I came to UTHM in 2014. Okay, here are some grants. You will get the idea of the title, things that I do. In 2009, 2011, we have learnable conversational agent, conversational act theory. This for FRGS. This is very fundamental. It falls under the natural language understanding part. And then 5 years later, not 5 years, 5 years later, many years, I did put up a proposal in different year from 2013 until the last one, 2019. It is not successful. I remembered when I go for the presentation in 2013 in e-science. So the comment by the panel was that they were concerned because the technical issues, the complexity is on the coding. So they were skeptical if the program could be successful. Okay, and as I mentioned, it's very difficult to get grants for this, and there are many available system coming on, like Google now. We have a lot of automatic translator that are available in the market, and this kind of topic is very difficult to go for PhD as well, because if you remember, I did propose for my PhD, and the reason it was rejected was it lack of academic value. Okay, so as a system, we cannot, it is actually suitable for master's level, definitely for undergraduate level, for project based. And if you want to pursue at PhD level or master's by research, then you have to go to the fundamental part, either in natural language understanding, natural language generation, the dialogue acts, and remember the figure that I showed you just now. Okay, so I give here is the Java implementation of ELIZA. If you want to try out, I give this for my undergraduate students in UPM those days. It's already constructed in classes, different classes. So you just have to modify the program. what happened when I came to UTHM, the idea is not, natural language is not so popular here. So you can contact me. I can give you sources if you would like to do this for your final year project. Some ideas from undergrad work. These are totally undergraduate work. I co-supervised with my ex-student, Dr. Vinotini. It was my ex-student, my PhD student, and she is the master of Verbot. So she used Verbot in her AI classes. And basically, Verbot is a chatbot program that you can modify and do many interesting things. So these are some examples that you can get idea of what to do with it. Okay, we have a typhoon assistant chatbot. This is the interface to manage natural disaster. And there was a TICTAT. You see this robot? TICTAT is a chatbot for learning visual C# programming based on expert system. Excuse me. And then Flow, intelligent flood aid chatbot as virtual flood assistant. And C-Pro, chatbot for teaching C programming. Aira, case study of Asia, chatbot for travel. Okay. So those are just examples. There are a lot of domains that you can explore with chatbots. It makes a very interesting project. It will make your supervisors or your lecturers happy to do that, And the one that we built a lot more, but the one that I've shown you are those that are able to get published in Scopus journals and proceedings as well. Okay, so as a closing, I don't want you to miss the movies too. From Chatbots, if you remember, 2001 Space Odyssey. I don't know if you have watched it. You were very, I don't know what generation, Y, Z generation you are in now. Space Odyssey was published in 1968. Okay, so this is a very, very popular script. Open the port, bay door, hell. Okay, and finally, the Humanoids. You should watch this movie in 2001, Artificial Intelligence. So AI is more about humanoids. So it is two different spectrum, chatbots and humanoids. We'll see that chatbots, it concerns on your conversational ability, but for humanoids, we go for the expression, the realism. So it's mecha versus organic versus mechanical. Okay, thank you so much. Back to you, Chairman.
Thank you very much for Dr. Aida for the interesting talk about the conversational agent. Okay, so this is basically the trends now that most of the intelligence systems are able to communicate with the humans. So any question from the participant regarding this topic? Basically, we have a question from the audience in the chat. Is Turing test can be applied in social science fields instead of maths and engineering in order to identify way of AI inquiry to determine human beings thinking?
It depends on the area or the research problem. Now, Turing test is basically to detect, to evaluate conversation ability. So we want to make sure the conversation by the system is sophisticated enough as in user. So I'm not sure in other domain like social science whether it's suitable, but if you don't see it anywhere from the literature, then I don't suggest. But if you see it, if you found it used somewhere, then it's a good way to start. Okay.
All right. So how far the trends of the chatbots in Malaysia context for the Malaysian language? Is there any other bots in Malaysian language?
I have friends in UKM, and there's one, I think Dr. Abdul Rahman from Unit 10 that built faster. But basically, in Malaysia, to my knowledge, we are more concerned we are focusing on the language, on the parser itself. but not in the sense of building a chatbot in Malay form. That I am not aware, and I've been lost in touch with this area for quite some time as well. But if you see, the technology is very old, and if you remember from Eliza 1966, and then there was an AI winter, what we call the phase in AI, and then comes now is 2001, and I did these chatbots in 2003, like that, 15 years ago, and still now we have started to see bots. You see in WhatsApp they use bots to do, but it's very primitive. Um, the technology that reach to us now is very far behind. It's even far. It's even far from template based. We still sometimes we have to choose, right? There is a pre-recorded option like 0, 1, and 2. It's very, I would say, very slow. So it is time. Your students, all of you should go and do something. And the other interesting thing to do is that while don't focus on building a Malay chatbot alone, because in future, like now, we don't do texting a lot, we do voice a lot. Okay, we even do voice message in WhatsApp for the sake of so-called saving time. So speech synthesis, you go for speech, building a speech database for Malay language. And what you can do is you can collect all these different dialects, all the Chinese language, and then all the Javanese, and build that speech, so that later, whenever the technology really comes to Malaysia later, we are ready with our local context. So we get the system, and then we can feed in with our own, ways we can pre-record our voice to replace the voice that gives the direction. So at national level, I think we should start doing that.
So I think, is it all the chatbots contains the intelligent features? I think not all, right?
Now, at the basic level, it's all pre-recorded, okay?
Pre-recorded.
But it's pre-recorded. And it is intelligent when the natural language understanding part can go up until the semantic or pragmatic level, where you can know the intention. Just as I mentioned, when we ask our partner, please give us a pen. So rather than saying yes, I can you please pass me the pen? Yes, I can. No, we don't want that. We want to actually pass the pen. So that is intelligence. But pre-recorded, no. But to the least point, there is a randomness inside. So that's what makes it interesting, like Eliza and Perry, because it's random response. And we human, we live in a random world. Okay?
Because nowadays we have several chatbots like Ava for Asia, and we have Putri for Plus Highway, right? Before they delegates the requirement from the customer to the particular customer service who in charge in that particular part. So this kind, I think this one is a kind of chatbots, but maybe do not have some intelligent features inside.
Yes, I think the most they go is until frame based. Okay, and chatbots in business, I think they will save, like I think I read somewhere 8 billion or 80 billion in customer service and all. It saves money. Rather than setting up a call center, we better have a chatbot. And usually, what makes it good to build chatbot for that industry, because users don't linger around to ask for nothing. They have specific question to do. So that'll be a good way to go as well.
All right. So any other question from the audience in this hall? So if there is no question, so I would like to thank Associate Professor Dr. Aida for the very interesting talk on the conventional agents. So in that case, we end up this webinar series, and we meet for the next webinar series 9. Thank you very much.
All the best.
Yeah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Waalaikumsalam.
Thank you.